What caused it? Over centuries, the Japanese side of the tectonic fault line had been compressed and dragged downwards by the Pacific plate driving beneath it.
The whole upper plate behaves just basically like a rubber block. It just compresses and like a spring like this, and when the earthquake happens, it springs back.
The sudden upward flip of such a huge slab of rock lifted a 6-kilometer deep mass of water upwards to the surface of the sea. As it collapsed back, immense waves raced out across the ocean. Not like normal sea waves, more like shock waves from an explosion. Just a meter high, but over 100 kilometers from front to back, and traveling at terrifying speed. One side of the wave hurtled out across the Pacific. The other side raced towards the coast of Japan.
Tsunamis travel very fast at a speed that depends on the water depth. And because in the deep ocean, tsunami travels very fast, reaching at times the speed of a jet aircraft.
At over 800 kilometers per hour, the wave took just minutes to reach the coast. Here, the shallower sea floor slowed down the front of the wave. The wave's fast-moving rear was still racing in. It began to catch up with the front. The increasing pressure pushed the seawater up into a rising swell. A massive aftershock has hit Tokyo, magnitude 6.2. In the week that followed the main quake, there were over 500 aftershocks along the fault. This is the actual data from seismometers around Japan. The larger the circle, the bigger the aftershock. As the Earth's crust shattered during the main quake, new stresses spread along the fault. Relieve the pressure in one place, and it builds up elsewhere, triggering aftershocks.
What you're seeing here is how those aftershocks happened over a period of about a week after the main shock. And that orange region, delineated by those orange dots, essentially gives you a feeling for the area of the fault along the plate boundary that ruptured in this event.